I've got a great video prepared for you today. Today we're going to be taking a look at the XGP Hurricane140mm fan and the Mobius140p ARGB. Let's jump right into the graphs and the data, and then we'll talk about the fan characteristics and do an open box experience. See timestamps below to basically get to the sections that you want to see. Data time. Alright, first up we're going to be taking a closer look at just kind of the listed specs of these two fans. So the Hurricane140 and the Mobius140p, both are pretty much bog standard dimension wise for 140mm fans. Both are 25mm thick, which is standard. The Hurricane has a fluid dynamic bearing, while the Mobius has a dual ball bearing. Both of them have 12 volt ratings. The power consumption in amps, RPM ranges for the Hurricane are 700 to 1800. The Mobius goes from 0, so it can actually stop RPMs, to 1900. So that's actually fairly similar. Airflow rating, the Hurricane is set to produce 91 CFM, while the Mobius is set to produce 76.5 static pressure. The Hurricane is rated at 2.2 millimeters of H2O, while the Mobius is rated at 2.3 millimeters of H2O. Noise levels are 28.1 and 30, and the mean time between failures, so this is how early you can expect the fan to, well, go bad on you. The Hurricane is rated at 230,000 hours, and the Mobius at 160,000 hours. Moving on and getting into the actual graphs, the first one we have is in my case airflow simulation test. So in this test, let's define what we're seeing. So I set 4 data points, 6 inches from the fan to my reading point, and this represents a small form factor case. Then the 9-inch, which represents a small case, but it's more like a standard layout. 11 inches, which represents a standard mid-tower, a lot like a Corsair 550D or the mid-size, mid-tier Meshify series. And then we have 14.5, which is a big case, a lot like the Fractal Design Torrent. Next, what kind of airflow do we want to see in this test? Well, 140mm fans tend to do better on this test. They tend to hold their air velocity better from the front to the back of the case. So in an ideal world with in my opinion, a perfect fan, there would be 0 drop in airspeed from the front to the back. And then that would be because the fan creates a perfect column of air through it. However, we don't live in an ideal situation. Even the best fan will shoot air off to the sides a little bit. The question is, how much does it do it? So the more air that the fan tends to shoot off to the sides, the less air it's pushing down the tube. So we'll see a steeper drop off in performance. And even more so, if it really is shooting air off to the sides, we're going to see it be less linear in shape and more like a parabolic curve downward, which would just be a very rapid drop in performance, which is, again, not ideal. So taking a look at the Hurricane right away, we can see that it is very poorly performing in the case airflow test. It drops off in performance rapidly, and as a matter of fact, I see a slight curvature downward for most of the lines, which indicates that it's really losing performance rapidly. Taking a look at the Mobius 140p, it is pretty clear that it is a good performing fan. It doesn't have a very steep drop in performance. They're fairly flat lines. We see a little bit of curvature in the purple, which is 1620-ish RPM. But they're fairly flat, they're very linear, which indicates that it should be a great fan in any case. But how do they compare to each other? Well, let's take a look at that graph next. And this is it. This is noise normalized distance from the fan versus airspeed. So again, distance from the fan, airspeed vertical, and we can see that the Hurricane, well, if you're buying a small form factor case that can fit a 140 millimeter fan, it should do actually fairly well. The problem is that anything bigger than that, it does very poorly. Its performance drops off very steeply. Mind, if you're looking at the 9-inch mark, it is still outperforming the Control, but the Mobius and it are functionally equivalent. And as you move further back in the case, at the 11-inch mark, it has met my Control, and by 14 inches, it's just dead in the water. My Control is a representation of two fans that have been meshed together using the power of math. It basically blends the Noctua A14 140 millimeter fan and the Noctua A12 X25. I found both of those two fans to be good in their respective categories, and I meshed them together based on noise level. Back to the data set, we see that the Mobius does particularly well. Actually, its behavior in terms of air velocity drop looks to mirror, mine at a higher airspeed level, my Control fan. So that is indicative of very good performance. And my key on the side has the RPMs that the fans are running at. Now, how do these fans run at 100% PWM? Well, here they are. The key on the side again, the RPM, and the noise level that I read. Again, did I say my margin of error, I don't think I've mentioned that, is plus or minus 1 meter per second in my anemometer, and plus or minus about 3 decibels in my microphone for noise readings. I would like to get better equipment, but it's just not on my scope right now. I need to get my channel bigger and more views or subscribers to my Patreon page to really get myself there to invest in some higher end equipment. But anyways, so there's the margin of error. So the Hurricane and the Mobius have functionally the same noise level, which is kind of surprising, but it's also a very good result. Taking a look at my Control fan, it is performing right there. The Hurricane does pretty bad. Just gonna leave it right there. The Mobius, on the other hand, looks excellent. It is maintaining its air velocity, fairly flat line, and it might just be a very high pick for case fan fans. Moving on to air velocity or speeds through my CPU AirCooler versus RPM. So this is airspeed versus RPM, and airspeed versus noise for left and right. And good fans are in the top left, bad fans are in the bottom right. So describing what we're visualizing with these graphs. So in RPM versus airspeed, what we're looking at is how good the fan is at moving air. So this is very focused on how good are the blades designed to push air, is basically what your key takeaway is. So if you watch like the Fan Showdown, like I do, you'll see a bunch of different fan designs, blade designs, and how much air it can push at the end of the day. This is very similar to that. So it's how good is the fan at pushing air. On the other side, we're looking at noise versus airspeed. So this is how quiet is the fan pushing all that air. And you could also use that as blade design, where it's how quiet is this particular blade design. So looking closely at the data, the Hurricane is a slightly better blade design. It outperforms the Mobius slightly through my CPU AirCooler. We'll get into this more in my focused view open box experience, but the Hurricane's frame design does not lead me to believe that it would be great in a pressure application as they seem to advertise it as such. Just too many gaps around it. I think that air would leak around it. Mind, I think it would do okay as a CPU air cooler, but not in a radiator. The Mobius, other hand, it is a well-designed frame and can be used on a radiator without any problems, in my opinion. I don't have a radiator to test on yet. I would like to be able to acquire one. Anyways, the Mobius and the Hurricane both are outperforming my control fan in terms of display efficiency. But how are they doing for noise? Well, that's when we jump to this graph. So the Mobius really is much better, especially at the very low end, than the other two fans. But as we start ramping up the RPM, it kind of loses ground and then gains it back again. But overall, I would say it's a good result. The Hurricane also looks like it does a pretty good job at distancing itself from my control fan. And then last, I like to take a look at CFM. So I like to look at my graphs in 3 point of views, how the case simulations to see how the fan dissipates air in every direction, or does it create a nice focused airflow. Then going through a cooler, because then it's a more restrictive airflow. The cooler is also a good representation of a small form factor case where you tend to need more of a pressure optimized fan. And then last, but certainly not least, is CFM, where it's sort of just how much performance is in this fan anyways, because it's all just being traveled down a tube. So the fact that the fan shoots air off to the side tends to matter quite a lot less. Mind you'll still see performance differences between fans that shoot off to the side versus one that's more focus flow, but it matters kind of less in this situation. So we can see that in the RPM versus CFM, the Hurricane is better, the control is in the middle, and the Mobius is actually the worst in this case, which is kind of surprising considering that it did so well in the other two categories, which is why I look at all three. And then in the noise versus CFM, the control is here, and the Mobius and the Hurricane are well above it in this metric. XPG Hurricane140. CoolerMaster Mobius 140 ARGB. Now we're going to take a further step out and compare these fans versus not every other fan, but a substantial portion of other fans that I've tested, primarily looking at 140mm class fans. So we have the ranking, more or less, by airspeed, and on the bottom here, you'll see a number with a W. And I recently did a video where I tested out my CPU air cooler across a number of fan RPM ranges to see what wattage my CPU would draw at that air speed. So that at that PWM signal, both with two different fans. And so with that, I was able to sort of backwards calculate what wattages would be associated with that. So if you have a fan that's producing 0.5 meters per second of air, you're looking at 130 watts if you have my exact air cooler. Or if you have a fan that is running at 1.5 meters per second, you're looking at 210 watts. Now, do you have the same air cooler as me? Yes or no? If the answer is yes, then you could probably use this data exactly. But if you don't, well, then you're going to want to take a step back and use it as, hey, I have a Noctua F12 on my cooler right now. So at noise normalized values of 40 decibels by Bill's readings, Computer Tech and More's readings, that 40 decibel reading is based off of the Noctua A12X25, in this case running at 1200 RPM, which I found to be darn tootin' near silent, basically almost completely inaudible. So that's how I would use it. It's like Okay, this guy found this fan basically completely quiet at this noise value. I have this fan, it is running at 0.7 meters per second. Well, if I swap to the Mobius P, I can run it at a higher RPM and get 1.3 meters per second of airflow, which will greatly improve my performance. My CPU, my unlocked CPU will now run at a higher wattage, giving me more performance. My locked CPU will run at whatever wattage it's running at, but will now run cooler. Or I can back that fan off a little bit and run the fan and make the computer even quieter. So that's how I'd use this data. So at the top here, we have the Hurricane140, its RPM range 1,400, and it moved 1.5 meters per second of airflow, putting it at the top of the graph. The Mobius140P ran at 1,300 RPM, and it moved 1.3 meters per second of airflow, making them towards the top of the graph. You'll see in here, I have the Noctua A12X25, a 120 millimeter fan, just as a data point. Here's the Noctua A14, which I consider to be a very high-end fan when I tested it originally. So you can see that things have been shaken up since I made my original control fan. But I'm leaving my control as is because I want all my data to be consistent going into the future. But let's take a look at how things look at 100% PWM signal. All right, now we're at 100% PWM. Same sort of thing on this graph. We have the wattages for applicable air speeds versus the airspeed ratings. So right here at the top, we have 3,000 RPM fans. I have the Noctua F12, the Noctua A14, and both these are IPC from Noctua, running at basically 3,000 RPM, and they're very noisy at 69.5 and 64.5. The Silent Wings 4 Pro 120 ran at approximately that 3,000 RPM mark. Its noise level at 53.4, but it does lose quite a bit of performance at that airspeed, so it doesn't have the same sort of top end. Moving on through this graph, we can see other key fans: Silent Wings 4 Pro 4 140, the Tough Fan 14, and here's the Mobius140P. It has approximately 2,000 RPM. I got a reading of 1,920, which is within the margin of error variance with it for these fans, and it moved 1.9 meters per second of airflow. So it is a little bit off from the top end fans, but it still is a good result for the fan. It makes it functionally the same performance level as the Noctua A12X25. The Hurricane is right here. Sorry, I appear to have missed highlighting them in yellow. And it has an RPM of 1,685 at 45 decibels and 1.8 meters per second of airflow, putting into a little bit lower grouping of fans, but still not a terrible result, just not as good as other fans. So again, I would use this data to figure out what kind of performance level you want from a fan and what noise level you find acceptable. Taking a look at more or less that same data, just from a different perspective, we have airspeed versus decibel readings. Better fans are going to be situated higher in this direction. Worse fans are going to be situated in that direction. So here's the Hurricane. It starts off pretty poorly. Not terrible, but pretty poorly. Mind, it is in a good direction, just not a lot of air speed. And it climbs pretty high and makes it sort of near the top of the graph, but then it kind of dead ends. It doesn't have the same top end performance. Meanwhile, the Mobius actually performs very, very well. It loses a little bit as its noise level goes up, but it's never away from some of the top fans in the graph. Other top ones to note: Silent Wings 4 Pro 120. This blue line represents the Noctua A12X25. This purple one is the Noctua P14. Some pretty poorly performing fans are like the P14. And this one is the Silent Wings 4 Pro 140. It just turned out to be a fairly noisy fan. Some notable good performing fans are like the Unifan SL. It performed well until it just runs out of steam and doesn't have any more performance left in it. Taking a look at these 140mm fans in my case airflow test compared against each other. Well, we're going to go through this quickly. Right here is the Hurricane, absolutely terrible, and this noise normalized graph, while the Mobius 140p is right here at the very top of my graph. It is by far the best airflow fan in this 140mm size that I've tested thus far. So I pretty much heavily consider that at this point, outperforming the likes of the Silentwings 4 Pro 120, 140s, Warner Snails, the A14s. They're all just in here. The Mobius just crushes them. At 100% PWM signal, the Mobius does technically drop in position, but it's an excellent result. It's a fairly flat line, especially once you compare them against each other. So it's a great result. As for the Hurricane, it's once again a fan that should be ignored in a case airflow. If you're wondering what these top fans are, this is the A14 3000 RPM Redux, or not Redux, IPC, and it's just winning by brute force. Right here we have the Silentwings 4 Pro 120. The green one is the Silentwings 4 Pro 140, and this blue one is a Top Fan 14. Taking a look at these data points from a different perspective, we have air velocity, noise at the 6-inch mark in my case test. I chose not to do it at other data points because it was just so hard to get readings at like the 14-inch mark, and I felt the 11 would basically drop a lot of fans out of criteria that didn't necessarily need to be. But the Hurricane is right there, actually performing okay for its given RPM range. And the Mobius is right here. So again, the 6-inch mark is where the Hurricane performed particularly well. We're going to move on. And now we're looking at noise normalized CFM. So that's cubic feet per minute. We have the Mobius, we have the Hurricane. The Hurricane produced 108.6 CFM in my testing apparatus. The Mobius produced 82.5, which is a very good result. The Hurricane is just better at doing this test. So depending on what is important to you, you should select whichever fans make the most sense to you. The control here is based purely off of a 140mm fan because my 140, 120 millimeter test apparati, is that a word, are different. And at this noise normalized value, the lian-li SL Unifan SL does particularly well. Looking at things at 100% PWM signal, we start to see a little bit of shakeup in performance values. The Mobius 140p produced 110, which puts it under like the Noctua P14, but quite a bit better than the Unifan. The Hurricane, on the other hand, is producing 1.27 cubic feet per minute of airflow, which puts it better than the Silentwings 4 Pro 140, which is substantially noisier. Or did I say better performance? Similar performance for a lot less noise. The P14S, it outperforms for less noise as well. So making the Hurricane a good fan when looking specifically at CFM. Looking at the data from across its different CFMs and decibel readings, we can see that the Hurricane is actually a very good performing fan. The Unifan SL140 is right here. It performs well, it just doesn't have the same top end grunt as other fans. The Mobius 140 is at the top of the graphs. Very similar to the Unifan, it just has a better top end. Other fans to note on here are the P14 from Arctic. It performed particularly poorly. And up here we have the 3000 RPM A14. So it gives you a good metric for how these fans stack up. All right, let's move on to our open box experience and do our fan analysis. Now that we've finished going over the data, and before I do the open box experience, I want to remind all of you, my viewers, that it's thanks to viewers like you who help with my Patreon page that really make all of this fan testing possible. I'm buying these fans out of my channel's money, basically my own money, and buying all this test hardware and spending my time to review these products. So I really thank you all for supporting me in Patreon. I really appreciate it, and I really appreciate you all watching the videos, because it's viewers like you that also make this channel possible with the view count and subscribing to this channel. So please subscribe and please consider checking out my Patreon page. Anyways, let's get into the open box experience. So first, I want to talk about the Mobius140 ARGB. It comes with this little bracket and some screws, and that's it. On the box, it's got some pretty colors on it. Okay, good. Some performance information, just RGBD, Asus, Gigabyte, MSI, ASRock, so pretty much the standard big players in motherboards RGB. Let's go into the fan. So this fan is very reminiscent of the Noctua NF-A12X25 in terms of the way the blades look. As a matter of fact, it looks near and identical to the 120mm version of the exact same fan. And in the middle, you can see it's a 4-pole motor, which is a little bit surprising considering how fast that it can actually spin these blades. Yeah, I'm very impressed, because most fans that would be able to spin it as fast as this one can, I would think would be a 6-pole motor. So let's go over the housing. It's got a very squared off design, which means it's very good for pressure applications in terms of sealing around it so that no air can escape, because air wants to escape, and when it escapes, it reduces the efficiency of your fan and make it so that it doesn't perform as well as you want it to cool off your, well, radiator or components. And while we're talking about that, in my pull configuration test on my heatsink, I found this fan to be silent. So this was great as a pull on a heatsink as well. And you can see a little bit of this curvature leading into the fan blades, and actually there's a little bit of this, a lip. So you slide down and then instantly hit the edge of this blade, or the housing right there. So that's kind of interesting. It means that the air gets guided and then could actually hit that, which potentially could actually be reducing the performance of this fan. In terms of the gap around the edge, I give that in the category probably an A, high A, not quite A+. But definitely good enough. So in fan designs, you want it as close, the blades to be as close to the edge of the housing as possible, because that improves the pressure characteristics and airflow traveling through the blades themselves. So having essentially your housing built right into your fan basically means that it's perfect. However, you still have a little bit of gap around the outside of the ring that air could potentially travel backwards through, but it's fairly unlikely. The ring does increase the weight of the fan blades, which means that you need a more powerful motor to get it spinning at those higher RPMs, which we already kind of went over briefly. We'll take a look at the RGB in a second. This is the CoolerMaster Mobius 140mm size fan, ARGB appearance. It features 8 RGB lights. They're a little bit hard to see on camera. I'm trying to get the color get there, but you can sort of see the brightest lumps in there. The diffusion through the blades looks pretty good. I'm going to go ahead and turn off the static color so that it can just do cycling color appearance. It definitely gets weaker as it gets out toward the edges of the blades, and the transitions aren't the smoothest because there are only 8 LED lights inside of it. Especially on a fan this size, I would like to see at least 2 more LEDs in it. I think it would really help with the transitions and color fusing, dispersion, that kind of fun stuff. But it overall looks fine. I think it looks better doing a static color than a cycling color where you can see the changing. Or if you were going to have like a couple sections, like 1, 2, 3, 4 sections or something like that, then it would look pretty good. But this color cycling, not as much so, in my opinion. From the back, looks pretty okay. Not great, not bad. Definitely better from the front because of the posts. But I'm more into fans for their performance. If you're more into it for their RGB, well, it's just fine looking. I'll let you make your own opinion about it. Anyways, let's go on to the next section or the next topic. Personally, I don't have an opinion about the RGB per se. I care more about the fan performance, and then RGB comes second. So I'll let you decide that for yourself when comparing this fan against all the other ones that I've tested, whether its performance characteristics meet what you want, or whether you care more about the RGB and its performance is basically just acceptable. Or not acceptable, but you like the RGB and you're going to use it anyways, or you're going to go somewhere else. The cable management looks fine. Pretty standard. 2 cables, nicely sleeved. And it's got the second connector for daisy chaining. That is fantastic. In terms of the blade shape, they're definitely, these are fairly thick blades. And they have a little bit of a curvature on the bottom, but not much. The top feels much more sloped. It basically feels more like a traditional wing than a lot of other fan blades. So what I mean by that is the top has a lot of curvature to it while the bottom has very little. I'd be very curious to run a fluid dynamic model comparing this shape to another fan that has a more curved bottom and a smoother, flatter top, or one that has essentially the curvature equally on both sides. But it ran pretty well in the testing, so CoolerMaster must know what they are doing. It's got a little bit of flat tips here, so I guess I need to bring up the elephant in the room. I am an engineer. I have a background in computational fluid dynamics as my master's degree. So this is an area that I am fairly knowledgeable in. Unfortunately, I just don't own the software to run these tests at this time. It's definitely something I'd like to be able to do in the future. But yeah, I guess I don't have anything else to say about this fan right now. Let's jump to the next one. One quick note about the Mobius 140mm fan. I noticed that sometimes I get a little bit of a ticking noise, and I think the fan sometimes rub against the poles in the back, and I just had to push the blades forward. So do note that if the fan is noisy, it's because it's doing some behavior like that, and I think it might just be a quality control issue, and it doesn't occur all the time, so that's why it doesn't appear in my tests, but I did notice it from time to time. Alrighty then. The second fan in this group that I took a look at was the XPG Hurricane 140mm. I did take a look at the 120mm version of this exact same fan, and I decided to take a look at the 140 one just for, I guess, completeness. While I'm thinking about it, in my pull test, I found this to be slight high-pitched noise, but in terms of its noise volume, it wasn't too bad. So I'd put it at the acceptable range, but not great. Open box. It just came with some screws. That's it. ARGB. It worked with my motherboard. Yes, it has Aurora, Gigabyte, MSI, ASRock. It's got some performance stuff on its graphs. But overall, very little information. I like their little character picture. Looks pretty badass to me. Anyways, it's got nothing to do with the fan. And here we are. Here's the fan. So they do declare this fan to be good at high pressure, high static pressure. But when taking a look at this frame, air can escape. Air can escape. Air can escape. Air can escape. This frame is not designed for high pressure applications. So even if it does have those good characteristics, they're losing a lot of performance on the table with this frame. And XPG, if you're taking a look, if you manufacture this fan or someone else manufacture, tell them to put a square frame on this fan. It will improve the pressure characteristics 100%. Well, maybe not 100%, but it definitely will improve the pressure characteristics. Mind, it did well on my heatsink, but airflow fan, this is not. Let's go over the cables. The cables are black. They're not sleeved. They're good in length. Here's it's got the second connector for daisy chaining them. However, they are pretty long, so it's still a lot of cable to hide. And it's got the ARGB good for daisy chaining. The back of the frame, the struts are kind of rounded off and angled more towards one side than the other. The bigger one here is basically just flat on the top, so you lose a little bit of performance hitting that. And let's see. As for RGB, let's take a quick look at that. This is the Hurricane140 millimeter size fan in ARGB glory. I have it set to my preferred static color right now. It features 8 RGB LED light bulbs to illuminate the inner fan hub, and the outer ring is much harder to count, but bright spots look like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's too many to count. But the color dispersion looks pretty good. I'm changing the focus on it. That's why you see a color shift. If we get closer to the fan and change the focus, you can see the LED bulbs, the bright spots in there. Let me shift that focus back out. All right, we're gonna change it over to be a color changing mode so that you can see how the transitions look. So visually looking at it, you can see that the transitions on the outside hub look substantially better than the transitions going on in the blades. And that has to do with because the outer hub has more LED lights in it, so that there is less of a gradient between each of the colors as it shifts. So it makes it less noticeable, less of a jump in color. But overall, it looks pretty good. I personally think that 8 bulbs on the inner rotor is not quite enough for a fan this size, unless you prefer static color like me, or are going to do it in quadrants. So that would be in 4s. Then it would look okay. As far as the front and the front has this ring and great glory. If you look at it from the side, if you were to use this on, I don't know why you'd use it on a radiator, but if you were to use it on a radiator, that's the way it would look. And from the back, looks better than average from the back because of the red light ring, but I would still say it's not top tier from the back. So I would give it, I don't know, if a fan without lights is a F, this would be a C, I guess. Either way, I think it looks okay from the back. But it definitely shows off a lot of illumination. You can tell from the back of my case how bright it is. Anyways, I'm not an RGB expert. I don't have much of it inside my case, so I don't have a lot of opinion about its appearance. So I'll let you yourself decide about it. And let's move on to the next section. Now that we've looked at the RGB, I selected this fan because I thought it looked really cool. It's got the rubber dampeners right there, but the blade design on it just looks very unique. There's no other fan I've seen with this type of blade design. So the blades spin in this direction, right? Which, if you're kind of looking at this, it almost seems like it's like spin in the other direction. I don't know. It just looks really interesting. Or have this other blade be closer to the front. I don't know. But in effect, what's going on is as this spins around, these ridges, these grooves, guide the air. Where's a good one? Guide the air into this, right there. And these little squared holes in the back then direct the air wherever it's going to go, sort of like a duct on an airplane engine. Whether it's really doing anything, I'd need to run the simulation to really test. It looks really cool. I know this definitely straightens the air and helps keep the air from sliding off the edge of the blade and into the gap around the outside where it would lose performance. Because, like we mentioned with the other fan, you want to get this gap as small as possible. But so it helps prevent that. And then you have this nice big opening so the air would slide and hit and kind of whoosh between this double wing. And it is a really unique fan in its visual appearance. Whether you like it is another matter, but it's just a very unique looking fan. And the last little bit is the general blade shape and design. So these are thicker blades that tend toward a pressure optimized appearance. So pressure optimized fan blades tend to be wider with a lot of overlap, and you get quite a bit of overlap actually with these blades. And these do have a good amount of curvature on the back for that hybrid nature to help accelerate the air out the back. So that's why I kind of think that it got the performance characteristics that it did. But it's just very interesting and makes me really want to run like some crazy tests and like dismantle pieces of this fan. Just like, what does this piece do? What does that piece do? What does this one do? It's just a very unique appearance. But let's move on to the next section of the video. Now that we've done our open box experience, I want to take a look at performance per dollar. Before we talk about what this is, I want to talk about the price of each of these fans. The Hurricane is a $36 fan. The Mobius, on the other hand, is a $30 fan. So now, what are these graphs going to be taking a look at? Well, this is performance per dollar. So we take whatever the performance is, meters per second or cubic feet per minute, and we divide it by how much money the fan costs. So a very cheap fan that performs pretty well is going to rank very highly on these graphs. So if you're looking at pure performance, you're going to want to refer to the data that I previously collected. If you're looking purely at it from a budget perspective, I have X number of dollars to spend on my computer, and I want as good performance as I can get for my money, then you want to heavily consider this. And if you're going, well, I have enough money to spend and distribute however I like, but I want good value, then you weigh both sides of this. So taking a look closely, the Mobius and the Hurricane kind of do rank toward the top of the graphs, especially considering they are RGB fans, but they're not the best. Again, this is the 6-inch mark. Once we're looking at 100% PWM, they kind of drop off. The Mobius hangs on a little bit better and it's kind of middle of the road, but the Hurricane is kind of drops back quite a ways. Moving on to the 9-inch mark in that performance per dollar metric, the Mobius, once again, is actually very, very highly rated, especially in the 140 millimeter class. If you're comparing it versus the 120s, it doesn't rank quite as well. So it depends on what size fan you want, but I don't think you could go wrong with a Mobius 140 looking at it from this perspective. The Hurricane is a little bit worse. It's still okay, but it's a little bit worse. At 100% PWM signal, they're both still okay, but they've dropped to more like an average mark. The Mobius is a little bit above average, but the Hurricane is basically sitting right at average. Moving on to CFM per dollar, at noise normalized values, the Hurricane actually outperforms the Mobius in this test. But the Hurricane did well in the CFM testing. It did a lot more poorly when we did real world test situations. So depending on what kind of case design you have, you could actually find that the Hurricane is a better fit for you. But broadly speaking, I would say that the Mobius is a better fan, but this is the performance value that I saw in CFM testing. When we're looking at the 100% PWM fan signal, we see that the Mobius and the Hurricane are very similar, with the Mobius just barely beating it in this metric. Moving on to the last performance per dollar that I did is performance per dollar running through my CPU AirCooler. I know a lot of other reviewers do temperature, but at some point it's really hard to tell how much heat the fan is able to get off. I think it's much more reliable testing to do air velocity, so that's what I ended up doing. But anyways, in noise normalized values, the Mobius and the Hurricane have very similar results, but with the Mobius outperforming it by a little bit. Both are towards the top end of the graph, particularly looking at 140 millimeter fans. When we take a look at the broad scope of all the fans, we see that they are sort of more middle of the road. Moving over to 100% PWM fan signal, we see that they've kind of shifted back a little bit. They're not terrible fans, but they're not quite as good as several others in this value category. But they're certainly worse ones you could get. Now that we've finished kind of going through the value proposition of the fans, let's go into the conclusion.
Thank you very much for watching this video. Please subscribe for more content. I have lots more fan videos coming up, as well as lots of fan videos that have been previously published on my channel. Please check them out.
All right, now at the very end of my review, this is the raw data that I collected from doing my fan testing. So we've got the XPG Hurricane, and then we have the Mobius 140p. If you would like to use this data in your own analysis or review, you are welcome to do so. However, in any publication, I would ask that you reference me as the source of this data, because I'm the one that spent a lot of time collecting this data, and I should be credited with collecting it. But anyways, all that said, thank you for watching. Have a great day, and I'll see you next time.